If you've spent any time online recently, you'll have probably come across images entirely generated by artificial intelligence, all from a sentence. There's no denying that these AI models, like DALL-E and Stable Diffusion, two of the most famous text-to-image models, are drastically improving at what feels like an ever faster pace. There are basically three different components to making these projects possible: hardware and algorithms, a lot of data, and training datasets. This last piece requires a huge amount of manual work, but this is what enables a lot of this research. Projects like ImageNet and Coco have been instrumental in recent progress in computer vision. Without these training datasets, there simply isn't any way to benchmark new research. That's what the Radiant Earth Foundation is working on for satellite imagery. Today I'm talking to Hamid Alemohammad, the Foundation's previous executive director, which is now on their board, about their mission. They recently announced the launch of LandCoverNet, inspired by the name of ImageNet, a global benchmark for satellite image classification across many different areas over the globe. Before we get started with the interview, I want to thank today's sponsor, which is OpenCage. If you work with addresses and location data, chances are you're going to need a geocoder. Geocoding is the act of translating coordinates, so think latitude and longitude, that are created by smartphones and tracking devices into human understandable places, like street names and place names, or the other way around. So OpenCage provides a geocoding API, which is built on top of open data sources, one of them being OpenStreetMap. This allows them to provide their geocoding API at a pretty low cost, as well as having pretty loose licensing terms compared to proprietary platforms. So you can do things like store the data as long as you want, display it on any map, and use it publicly or behind a firewall. So if it's built on top of open data sources, you may be wondering, why wouldn't you be able to do it yourself? Well, you can totally make your own geocoder, but what OpenCage provides is just a simple API that works, that is reliable, basically to take care of all the maintenance. For example, OpenStreetMap alone gets edited 4 to 5 million times a day. On top of that, OpenCage provides information like local time zones, what currency people use, and which phone code is used. Because OpenCage is based around open data, that means their pricing is also pretty affordable. And they have a pretty generous free trial that I encourage you to go take a look, especially if you're just playing around or are doing a personal project. Finally, which is pretty close to my heart, they've been long supporters of the open source community and just geospatial community as a whole. So if this sounds interesting, you can go to the link in the description to see more about them. Hi Hamid, I'm quite excited to have you on the podcast today. I'm quite excited to have this conversation. I don't know if you know, I start these conversations with the same question every single time. I'll asking people how they would describe themselves. So I'm quite curious, how would you describe yourself?
Hi Maxim, thank you for having me on the podcast. So I would describe myself as both a researcher and executive. And working at the intersection of machine learning and Earth observation. Particularly, I've been interested in how we can better use Earth observation data for policymaking and decision-making, how AI and the rapid advancements in the cloud technology can help us better use the data. And in my capacity, at some point, I have been fully engaged in a research level kind of projects, and also to some extent at executive running a team and organization who has been primarily focused on machine learning and Earth observation.
I'd like to get into both of those things because they sound quite different to me. But before that, how did you get into Earth observation, and why is that the thing that you want to focus on?
So I started my bachelor's in civil engineering. It was a general civil engineering degree. You would take various courses in civil engineering, from road, from construction, buildings, and also environment, particularly hydrology and similar courses. And that's where my interest kind of spiked about how we can better monitor an environment. I'm originally from Iran, and I had seen firsthand many environmental problems, droughts. My grandfather was a farmer. I would see how he has to deal with many kind of environmental issues, and particularly depleting groundwater levels. So I have been exposed to those kind of environmental problems. So I came from a domain, basically. So I was interested in environment. So for my master's, I specifically started in a water engineering, water resources kind of degree. And being also interested in everything space, I was like, how can I merge these two together, basically? That was the intersection. And I remember I did a good amount of literature review during my master's to see what is the kind of hot topic in the environment and space that a researcher can work on. And I landed on this WCRP report, World Climate Research Program, that was talking about the role of satellite data in monitoring sea level rise. This is in 2006, 2007. And that's where the interest came in. We started working with a satellite called GRACE, which is a Gravity Recovery and Climate Experiment. It's a joint mission between NASA and DLR in Germany. And I started using that data, gradually dealing with how we can do both sea level kind of monitoring as well as basically total water bodies of a watershed. And from there, I applied for PhD, still focused on remote sensing, and the rest is history that we can talk about. But the spike was really the intersection of environment and my interest in space.
Right. Yeah. And so you started on this researcher path before. You mentioned, researcher executive, but you started on really looking at it from a researcher's perspective. How could you bring those two things together?
Exactly. That was the interest, and originally it was just remote sensing. So I was using remote sensing data in a very physical, traditional way of doing remote sensing, building retrieval models. Particularly during my PhD, I was working on satellites that would deal with precipitation and soil moisture monitoring, and many of the models and research that I did was using a physical model, doing what we call inverse modeling, retrieving like soil moisture from those data, and also doing a little bit of statistics. It was there, but it wasn't machine learning back then. But I was dealing with a lot of images back then. So I had these images of patches of rain, and I was trying to build a model that would quantify their uncertainty. And talking to many friends and kind of people outside of my research vicinity, they told me, "Hey, look at ML, because that's this is like in 2010, 2011 that ML was really rapidly expanding. And those are dealing with patterns and image recognition. Maybe those methods can help you in your research." And that's where I started, because it was during PhD. So taking courses in computer science, some on computer vision, some on machine learning,
right,
and gradually applying those to my field of basically interest. And then more and more I got interested in that, and I started even working with more high resolution data then. And again, similarly applying the same technologies and methods to those data.
So you saw remote sensing data as interesting data. You had a problem you wanted to solve, and then slowly realizing machine learning, especially early 2010s, is a tool that's on the rise that can be applied to the data that you're working with. And so that's how you start looking into that.
Exactly. And even I remember the first time I applied something in computer vision world to my data, it wasn't ML in the sense that we think these days. It wasn't a convolutional neural network. It was the classical computer vision. You do feature detection, you manually hard code those feature detections, and you find patterns in the data. And I was solving basically a statistical problem, but I was using a lot of, back then they would call it pattern recognition, but these days it's all computer vision basically. But yeah, I came from a domain perspective with a problem in hand, looking for what tools can I apply to solve this problem.
So let's go a little bit on the Radiant Earth Foundation, because this is a perfect segue into it. Can you tell me a little bit how you started working there?
So after finishing PhD, I also did 2 years of postdoc, still exploring what I want to exactly do. So I was doing even more kind of machine learning on various types of remote sensing data. And then when I started looking for job opportunities, I was interested to be in an organization that works at that intersection. So I want to bring my technical skill set, but it's also closer to what I call the impact space. It is closer to the problem space. And I can have some leverage in terms of what I do. And I coincidentally came across an interview with the Radiant Earth CEO back then, Angel Minoresi, that was talking about this organization, how it's established. It was very new. It was less than a year old. This is spring of 2017. And I went on LinkedIn and out of blue messaged Anna and said, "Hey, this is me. This is my resume. I'm interested to join your organization. I think I can be of help. Within hours, she replied. It was surprising a little bit initially for me, but that was how it started, and the rest was history. I did an interview. Everything went well, and I joined September 2017 as a senior geospatial data scientist.
So it's totally worth reaching out to the people that you want
It
to
is.
talk to. That's the main lesson I take away from
It
it.
is a good lesson to learn. Yes.
So, okay, let's go a little bit on the Radiant Earth Foundation. How would, I asked you how you describe yourself. Like when you have to talk about, advocate for the foundation, how do you describe the foundation and what it does?
So foundation is I would say, unusual nonprofit organization because it is a technology organization. So it is working heavily on technology solutions, but it is a nonprofit business model, which is not typical in the industry. The reason it is like that and the role that it plays is that it acts as a neutral and trusted entity to build a solution. That solution is at the intersection of, again, machine learning and Earth observation. One pillar of work is building what we call Radiant ML Hub. So a benchmark repository for training data sets and models. So it's open access. Everybody, first of all, can publish their training data and models on that, and everybody can access the existing training data and models. Secondly, because we have that neutral, identity, we act as a catalyzer in the community, bring various stakeholders from commercial and non-commercial to work on standards and best practices, particularly in a very collaborative and open source way. The Spatio Temporal Asset Catalog, or STAC, that you have talked in the podcast about, it was one example. We started that in 2017. Again, our role was, let's bring everybody at the table and talk about this problem, build a solution. And the last piece is doing capacity development and training. Again, it is not just about the technology being out there. You want to make sure the end users have the capacity and knowledge to consume these. So we invest into capacity development and training in addition to the technology itself.
So that's one of the things I want to explore a little bit, like the whole nonprofit aspect. And you said it's not a usual nonprofit in the sense that it has tech. Tech is notoriously expensive to build. Like the people you have to hire usually ask for a lot of money for the skills that they have. The software engineering, project managers, all of that. How does the Radiant Earth Foundation get funding, make money, like to be able to justify all of the work that's done on that side?
Very good question. So Radiant, when it was established in 2016, it had a match funding from two big philanthropic organizations. One was the Bill and Melinda Gates Foundation, and the other one was Omidyar Network. And both of them did that investment because they also identified this as a problem, that there needs to be a neutral entity in this sector to build a set of solutions that everybody can benefit from. So our support as of now relies on some of those philanthropic, grants. We also have government grants. We have a collaborative agreement with NASA, for example. And those are always aligned with the mission that we have, or we build or expand features on ML Hub, or we build integrations with NASA, for example. We also have contracts with commercial sector that we, for example, work on generating a specific training data set, or things and solutions that, again, add features to the ML Hub. So we are not acting as a consulting in that sense that we do everything commercial in terms of consulting, but we do things that are aligned with ML Hub or end up with a new data set or a feature on ML Hub, basically. So those are the three kind of main revenue sources for us. We don't charge users for consuming the data as of now. There's definitely discussion, should we do that in terms of just throwing an example, this is not necessarily the model now. If a user is using too much data, or they are more of a commercial than a non-commercial, should they pay more? So those discussions are happening now, but which is more about sustainability in the 5 to 10 year window. But for now, we are very well supported by these three types of grants and revenue sources.
Yeah, that sounds like the common open source problematic as well. This is open, but then some company can come in and just swoop all the results without necessarily contributing back. I can imagine those are some of the challenges, or at least ideas that you might be playing around with as well.
To some extent, I mean, it is open source. Yeah, everything we do is open source, but it is different than a software open source, right? Because what we provide on ML Hub is an actual repository, an API, a data store, basically, right? No one is gonna get that from you and go away and do their own thing, right? They might just get the data and do a project internally that the license allows them, let them do that, no problem. The way we are thinking is like adding an extra layer of like enterprise solution for a customer who is interested in more than just the data, so they can potentially pay us to do that thing, which is an added value on top of the data they can get from ML Hub.
So I want to linger on the financial side as well. I like really try to understand that aspect of what the different incentives are for a for-profit company. It's pretty much easy. You want to make as much profit as possible and you sell the product. It's a relatively well-known, simple structure, I want to say. For the nonprofit, it's a little bit more complicated. Have you found that it was... how do you convince basically those organizations like Bill and Melinda Gates to continue the funding? Like, and what is it that they want to see out of the work, and how do you communicate that to them? Because it's a notorious foundation that's trying to solve a lot of different problems in the world, and this is a very specific, I want to say narrow one compared to at least the extent of the foundation. How does that dynamic work out?
Definitely, it's a narrow topic compared to the scope of a foundation like the Gates Foundation. And I would just highlight that for every funder, you need a different language. So the way we talk to the Bill and Melinda Gates Foundation is different than like McGovern Foundation or others. So that's one thing. You need to understand the foundation and their priorities, because they publish about their strategy. You can see their previous basically granting record. You meet with them and discuss the initial idea. You don't just submit a proposal. You really go and talk to the program officer. You get to know each other basically through that process. They know you, you know them, and you better understand if there is an alignment or not. If there is not, okay, that opportunity is not there. But if there is an alignment, and I will say specifically, for example, how it works with the Bill and Melinda Gates Foundation, you then pursue writing a proposal, doing basically iterations on that, convincing that this is worth investing. In the case of the Gates Foundation, the main example is their interest in agriculture or monitoring and generally agricultural productivity across the smallholder farming regions. So those regions are generating a significant portion of our food globally. More than that, those farmers are relying on that income for themselves. So it is not like a commercial farmer in the US that has tens of acres of a farm. They might have 1 acre or 2 acre of a farm, and they're growing something. They need to have a good harvest at the end of the season to feed themselves and potentially sell some of that to have a source of income. So it is very important for foundations like Gates to help those farmers have a better livelihood, whether it's through advisory services, whether it's through government support. And they want to basically empower the ecosystem. They don't want to build solutions. And that's how we come aligned with each other, because Radian is also not building solutions for that last mile basically problem. We are empowering an ecosystem with those training data sets and models. So a commercial entity, a government extension officer, another research organization, or a multilateral agency can build a solution on the ground for them. So that's how we become aligned with Gates, and we say, okay, these are the things we're doing. We see your priorities in this area. This is a match. This is what we can do with this X amount of money. Gates in particular has an initiative called Enabling Crop Analytics at a Scale, which we have been working with them for the last 3 years, both as a grantee and also on their technical advisory board. So we also provide feedback through that process to them, so they can make better decisions about their investment.
Right. Yeah, thanks for explaining that. So then I want to get into, we talked about the Radian ML Hub, like that's one of the big components of the foundation. Can you explain to me why that is the topic the foundation is focused on specifically creating the data sets, creating this hub that people can access? Like, why is that I'm guessing, highest leverage, highest impact? You were talking about the impact. I'm guessing it's highest impact thing that the foundation can be doing.
Yeah, definitely. So Radian ML Hub wasn't one of the original pillars of the work at Radian. It was born around 2018, actually, a year after I came on board. And the way we landed on this idea was initially we identified the lack of what we call geographical diversity in training dataset as a problem. We actually wrote a proposal to Foundation and got funding to work on what became to known as LandCoverNet, which is our first global training data set for land cover classification.
Sorry to interrupt you. What you mean the problem here is that you didn't see, I just want to explain to make sure like some of the people listening also understand. We're talking about, and correct me if I'm wrong, but the fact that in a lot of the training data sets that we have, there's not a good repetition of geographies around the world. So if you build models on them, they're not going to generalize very well to the world. They might have a very Western country-centric view.
Exactly.
Right.
Exactly. That's a good explanation of lack of geographical diversity, basically, or as we say simply, geodiversity. Because historically, many of these reference data sets have been generated in the Western world, particularly North America and Europe. So many of the labels, many of the reference data are from there. And when you want to build a model, whether it's a global model, you want to apply it everywhere, or a regional model in another country outside of these regions, you don't have good quality data. So the model is not as accurate, or it's not transferable and generalizable, as you said. And this is still an issue, but we are tackling it hard now. We are trying to get more investment in there. But we have started there. We have started at that problem, and we have started, okay, we need to generate better training data sets. And so we started on LandCover again because of its importance in many sectors, in many indicators globally. And through that process, and also running what we call expert workshop with the members of the community, we noticed that, okay, when we generate this data, how are going to people access it? We still have that problem of basically, there are two problems in this training data ecosystem. One is sometimes data is not there. Okay, we need to generate that. But sometimes data exists, but it's not accessible. It's behind a paywall, behind an email. You need to email someone. You can't even discover the data in the first place when it exists. So those themes started emerging that, hey, we need a better way of also serving this data. And that's how we came up with the idea of Radian ML Hub. And as the name says, it is a hub. It has inputs and outputs. You can publish data on it, and you can easily get data out of it. The name Radian was there because of Radian, and ML is machine learning, and Hub is basically that functionality. And the reason we were convinced that a nonprofit should do this is that, again, you want to keep this as an open repository for everyone. So there is no commercial interest in doing this, and you cannot expect a commercial entity to do this. And governments can do this, but they are much slower and more bureaucratic to come up with a repository like that. So it will take much longer for them to do that. And as of that time, there was no government entity even interested in doing that. So that's how we identified this is a role we can play. There is definitely a gap. And also, again, talking with various stakeholders, they resonated with the idea that, yes, it makes sense that Radian as a nonprofit do this thing. Let's embark on that idea.
Right. So that's really interesting. So it's important that it's not done by a private entity, because then the incentives don't align. But if it's then the other option is governmental, but the field of machine learning is moving at such a rapid pace that you need something that's able to be, let's say, agile enough to adapt to it. And so the nonprofit whose main goal is to focus on that is a good compromise between those two things. Do I sum that up pretty well?
That's exactly true. Yes.
And so how's that been so far?
A nice journey. Definitely bumpy. It is not an easy thing to develop something from scratch out there. But looking back, I have been at Radian for 5 years now. I feel very happy and satisfied with what we have achieved, both in terms of implementing and executing ML Hub and the way it has been received by the community and the way they are using it. So definitely it was worth investing in that. We have seen more interest even from funders to support this thing. And now we are seeing others talking about, hey, we need a repository for geospatial data, training data. I was like, we have it now. Many other organizations are coming to that basically conclusion now. There's a need for better way of sharing, whether it's just in situ data in terms of when you are on the ground collecting reference data, as they call it, in situ data, or the actual basically training data, basically bundled with source imagery and things like that. So there's a growing interest in solutions around training data repositories because more models are being developed, more people are working on solutions around machine learning and Earth observation, and the demand is just growing exponentially in terms of access to training data sets and also pre-trained models. So that's why we now have also a repository for models.
Do you have some numbers a little bit to try to get an understanding of like how many data sets or gigabytes of data are on the hub, and then on the other end, on the community side, how many people or requests do you get?
So we have around 70 data sets as of now. This adds up to around 6.5 million stack items. Those who are familiar with the stack, each item basically is one asset in your catalog, whether it's one chip or one label. In terms of I don't have the storage number. It's definitely in terabytes, but I don't think we have hit petabytes. That's where we stand these days. In terms of user, the latest number I have is around 6,100 kind of users who are using the data sets. I don't have the exact number, but I know we also look at which data sets are being used versus the other ones and collections. I don't have the exact number on that, basically. But anytime we launch like a dataset competition, our usage spikes because more people are using dataset at that time. But regularly, even on a single day, we easily get 100 or so requests just for various datasets. Even when no competition is running, there's no event basically running. Regularly, people access the data and use that.
So this leads on to the second part that you were talking about, the work of the foundation, which is the capacity building and building a community as well. I'm not sure if there's a difference between the two, but basically it's not just tech, it's not just code and data, but it's the people as well. Can you talk a little bit about the work that you're doing, or that the foundation at least is doing on that side?
Yes. So as you said, we need to go a little further than just publishing data and providing a technology solution, which is raising awareness and also providing capacity for the end user to consume this. We do this in various ways. Regularly with things that we publish on ML Hub, there's usually a tutorial or some Jupyter notebook we publish on our GitHub, and we promote that through our social media and our newsletter so people get aware of what is going on. Occasionally, we have run webinars specifically on a certain topic related to the datasets on ML Hub, and again, targeted a specific community. For example, one of the communities we work closely with are data science communities in Africa. You might know that there are two very well-established data science communities. One of them is called Deep Learning Indaba, and the other one is called Data Science Africa. They are basically grassroots organizations, people who are interested in machine learning, and they run annual kind of conferences in Africa around machine learning, also run trainings specifically for kind of targeted groups. So we have been working with them, giving like lectures in those conferences, specifically on machine learning and Earth observation and how you use datasets from ML Hub. Last year, spring of 2021, with support from GIZ, which is the German development agency supported by their Ministry of Development, we ran a boot camp for machine learning and Earth observation for participants from 4 African countries. I think it was Uganda, Rwanda, Ghana, and South Africa. It was during COVID, so we couldn't be in person. Everything was virtual, but it was like a 2-week boot camp, starting with the basic concepts of remote sensing and geospatial to building a machine learning model on your basically remote sensing data, and also focusing on the concept of what we call training of trainers. So we try to encourage them to be trainers in their community, go out and teach others about that concept. All of those materials from the bootcamp are now also on an online course available online that people can go through that on themselves and basically train themselves about those topics. This is really getting hands-on on training. In terms of awareness and kind of community information, we have a monthly market news. Our team basically gathers all the advancements in the field, catalyze them, and basically publish them every month. We do our quarterly news release, again, highlighting some of the achievements and the work with Radiant. The last kind of signature thing our marketing and communication team has done is a market map of machine learning and Earth observation. Who is doing what in this sector? We have published that the last 2 years, and the third one hopefully will come soon. But basically, again, acting as that neutral entity, mapping what is out there so everybody can learn about the advancements and the new players in the sector.
That sounds like a lot of different arms, basically, of what you're doing, of like capacity building, and then like some sort of analysis work that a consultancy firm might do about like, this is what's going on in this industry, and trying to map, which is notoriously hard to do as well. That sounds like there's a lot that's going on, at least on the capacity building.
There's a lot going on, and just so you know, the whole team is 10 or 11 people. So we do all of that. But yeah, I think we are so efficient in doing that.
So is 10 people, like, is that across the entire foundation?
Yeah, 11 people total across the entire Radianers Foundation, yes.
Can you break that down a little bit for me?
Putting aside the board, so I'm not counting the board, I'm counting the full-time people. So counting in terms of roles and responsibilities?
Yeah, can you break, like, what are, because we've talked about a lot of stuff here. Can you tell me, of those 10, 11 people, how many are doing what? What's the breakdown?
I have to count. We have 2 people in the marketing and comms. We have a project manager and the executive director. The rest are technical people. 3 of them are in data science, working on building models, building the tutorials, working on competition designs. And the rest are basically engineering team, as we call them, which primarily focus on the data cataloging, the API, the front end and the dashboard, the Python client, and everything in that. Yeah, that's the rough
That is incredibly lean.
It is lean, yeah.
Very small team.
Yeah.
Is that by design, or do you have like of trying to keep costs low or things like that, or is there this? What's kind of the direction the foundation wants to go in? Because as you grow, you were talking about the ML Hub as well. Like, we're talking terabytes of data that has a cost as well of maintaining all these things. So, where's the foundation thinking of heading?
Yeah, so a couple of points in there. In terms of size, we have been intentional in growing slowly, not suddenly going to scale, given that this is a uncharted territory in terms of nonprofits doing this thing. So we want to go slowly, but making sure we deliver on what we promise. So we haven't ever under-delivered on what we promised. We have always, I think, over-delivered, actually. So we have been very careful in what we plan to do and what we basically deliver. So in that sense, the size has been really matching what we can do. Definitely, there is more demand. There is more people interested in publishing their data, and we can talk a little bit about that. What is the challenge there? But the size is going to grow. Yeah, definitely, the team will grow. I don't think we are going to be 50 in 2 years, so that's not the way we are going to grow. But easily going to 20 or so is achievable and planned. In terms of cost, and you talked about the data store itself, so I should acknowledge that we have support from cloud providers, both AWS and Microsoft Azure, and basically our data bucket or storage is fully supported by them. And the main reason is, based on all, the cost of the storage is one thing. As you know, there's also egress cost. And that's a very variable cost that it is hard for us to predict and budget. So they are taking that on their
So
credit
that's the
card.
Cost of downloading and uploading the data, like transferring, moving the data around.
Yeah, particularly downloading. There's no cost to uploading. When you want to bring data to the cloud.
There is one, but they take it on. Like,
yes.
There's not for the customer, but yes.
Exactly. For the customer, there's no cost to bringing data to the cloud. But when you are getting data out, which is basically our users hitting our API, reading data, and I can imagine majority of them take the data out of that cloud region, and that's where the cost incurs. That's on cloud provider's credit card and not us. So in that sense, we don't have that variable cost. We only have the actual engineering cost. We have Also credits that sometimes we use for our resources that we are generating catalogs and everything. But the rest of it is basically labor and organizational cost.
So I was guessing that was kind of what was going on behind the scenes, that AWS, Microsoft Azure were kind of taking the cost on that. There's been a sort of rise of different platforms of trying to be the geospatial data platform. Microsoft building their Planetary computer. AWS has the Open Data Registry, where there's a lot of data sets. Google has Google Earth Engine. There's all these big tech companies trying to do that. Isn't the ML Hub competing in a way with those? And so if not, like, how does that position? What's their interest in supporting this effort? I'm playing devil's advocate here a little bit.
No, it's a good question, and I think that we should discuss in the community. So let me comment on one thing and then say how we are not competing with them. First of all, those three that you name have very different solutions. So AWS Open Data Registry, which is also supporting our data store on AWS, it's only a data store. So it says, this is an S3 bucket, this is the data there, and this is the entry on the website, potentially a contact, some tutorials if the data provider is providing them. They stop at there. There is no compute solution, right? There's no integration with a server that you can consume the data. You need to build your own, either an EC2 VM or getting the data out to your server. But
it's built on top of AWS infrastructure still.
It is built, yes. It is built on AWS. So it is easier for you if you go to an EC2 machine, which is the basically virtual machine on AWS, spin it up, use that data there. It is faster, easier to do that. So that's AWS. Microsoft Planetary Computer, as the name says, it is actually a computer. So you have hosted Jupyter Notebook servers that you can easily go there. It's already installed. You don't need to do any installation. You just log in with your account. You have a Jupyter server running, and you can start hitting their API, which is basically the same type of data you might find on the AWS Open Data Registry in terms of geospatial data, because the AWS one is broader than geospatial. And it uses all of the open source technology, including Stack and Pangeo in terms of its structure, and you can start building solutions. You don't need to think about your infrastructure at that point, unless you have higher demand for the number of CPUs or GPUs or RAM or disk space or things like that. Then you need to spin up your kind of customized virtual machine on Azure. So they go a step further than AWS in terms of solution. Google Earth Engine, on the other hand, so they are the first one in terms of providing geospatial data on a cloud, if you call it. It is different in the sense that the data that you access, it is not, to my interpretation, raw data, because they catalog the data, they store the data in a specific Google Earth Engine format, and they have a very good interface. So that's what they do best. That many people who are not necessarily a software engineer or a data scientist, but they're a researcher with some basic knowledge of programming, they can go to an interface, which is the code editor on Google Earth Engine, and start literally with a couple of lines of code, do an analysis, do a visualization on top of that. So that visualization is also a significant benefit there, and potentially run global scale analysis, but with the caveat that the resources are basically limited. So you need to sometimes wait for a global analysis, for example, because it's
a bit more of a walled garden, like bringing things out.
It's walled garden, yes. Yeah, taking things out, it is not easy. And it is designed for people to work in that ecosystem. Because it was launched about 10 years ago, it is not much I would call ML friendly. ML in terms of particularly deep learning. Yeah, you can do like random forest or typical classification problems there. But if you want to train a CNN model, a convolutional neural network, you can't do that in GE. You should take the data out into Google Cloud, train it there, and then put the model on the Google AI platform, and then hit that in the Google Earth Engine to get the model to run it in Google Earth. So there's a lot of complexity in there. Recently, they talked about connection between Google Earth Engine and BigQuery. So I think something is happening. I haven't looked into that. So hopefully new advancements will come in. So with that background, how we are different is that, again, we are not a compute solution. So we are not providing any compute to anyone. We are only focusing on training data. So we don't host raw satellite data. You can't get all of the Sentinel-2 catalog from us. And the focus for us is, hey, we need better standardization and I would say generally best practices about how we do machine learning. And that's not, again, an interest that the cloud providers have. We are basically helping them in some sense because we provide very high quality ML ready training data that users have an interest in consuming, and some of them are already on the cloud. And the way we serve the data through a standard API, it means it is interoperable. No matter what cloud you are in, you can use the data. So we are actually building a solution on top of their existing solutions and helping them do better. We had actually a contract with the Planetary Computer team for the last year that we build better integrations between ML Hub and Planetary Computer. So when you are in Planetary Computer, you want to consume ML Hub training data sets, it is easier to authenticate and access the data than going back and forth between the two basically APIs and the platforms.
Right. So the incentives for the AWSs and the Azures of the world is to make it it's still to get people on their platform. Like that's still the basic thing. But by helping the ML Hub, like they're helping everybody, but they're helping themselves out. And you've built that in a way that by them helping themselves out, it kind of helps everybody in the process.
Exactly. Yeah.
Right. That makes a lot of sense. And so another thing I want to understand is I'm still on this, understanding the structure a little bit. Back to a for-profit company, it's very easy to know which direction they're going. As line goes up or down, and it's how much profit they make, and that's on a quarter basis or a yearly basis, and that's how a lot of the decisions are made. How do you make decisions? How do you know if you're going in the right direction in an organization like Radiant Earth that has multiple different facets?
Good question. Yeah, it is different than the sales cycles that you would have in a commercial sense. But you can think about it in the early days of a startup in a commercial sense, right? In the early days, you don't necessarily have sales, right? You're prototyping an idea. You're going to some customers, see how much reception you get from them or how much commitment that if you build this solution, they are going to use it. That's how we basically assess our impact. So we have a hypothesis of what we feel we should do as a nonprofit. And the reason that we do it is identifying a gap. And then we talk to a funder or we write a basically proposal to a solicitation like the NASA of the world. And we get funding on that idea that we propose. We start building the solution and we try out and test it. We see, is there reception to that idea? That's how originally ML Hub was born. The initial grant that we got for ML Hub was very small. And it was like, hey, we have this training data set, the LandCoverNet we are generating, but we want to build a small API and test this thing out, which is publishing this data for the community to test it. When we launched ML Hub in December 2019, it had only 3 data sets, very small data sets. It was crop boundaries and crop types in East Africa, 3 countries. And we were like, we just need to go out and talk to people to see if this is what they want. I mean, we had already received good reception that if you publish, we're going to use, but that was the time to go out and have people actually use it. So we started launching a competition right after that to, again, bring more awareness of what is out there, have people use it, try the idea out. And the more we did this, the more feedback we got that you should do this more at the scale, you should do this. And we have now inbound requests. People say, why don't you have this training data set for this region? We are at that level now, which is like, hey, we don't necessarily generate the data ourselves. We do some of that, but it is more of a library. So someone should write that book, put it on our shelf so you can borrow it basically from us. But we are at that stage and we basically tested that hypothesis and it worked. The training is the same, training capacity development. There is increasing demand day to day that, hey, we need better training. We have organizations who come to us and say, can you come to us, give us this kind of customized lecture or training for these people who have this type of background and they want to learn this thing. Again, all at the intersection of ML and EO, but they come from different backgrounds. So there is a growing need and demand for that service in addition to the ML Hub itself.
Whenever I think about competitions in the machine learning spectrum, I feel like it's dominated by one name, and that's Kaggle, and which is being acquired by Google. It's starting to be a little while ago, which is trying to be this giant space of data sets and people as well. Like they're really trying to get those two things together. They have code and infrastructure now. I haven't been there in a couple of years, but basically you have hosted Jupyter notebooks that you can run against their also hosted data for their competitions. And it's also this kind of interesting place to have competitions because they're usually very open with a lot of discussions happening, and there's a forum that's built in. Have you thought about, or have you actually worked with Kaggle? I mean, there's other platforms, but I'm bringing them up because they're the biggest. And how are you thinking about that?
We explored Kaggle early days when we wanted to launch a competition, but we ended up not launching any competition on Kaggle because one of the main goals for us when we do a competition is also capacity development in low and middle income countries, particularly Africa. And the way to do that, it's not just running a competition, it's accessing a good network of people who can get to know about, oh, this is a competition, I can go in and compete. So let's go to that platform. So for that reason, we work with a platform based in South Africa called Zindi, which has very similar functionalities to Kaggle. Not all of them. They're not as advanced as Kaggle. They're a very early stage company doing that. But they have similar things. They have a forum. They have a good community that reaches out. They have the automatic submission and everything. They don't have the like Jupyter Notebook server thing.
Right.
So people are building solutions on their own machine or Google Colab or any other server they have access to. And they compete on that. In that sense, we have a broader reach to the community we are targeting in terms of capacity development. We have also worked with another one called Driven Data. They are based in the US, and we have had a collaboration with them too. They are more advanced than Zindi in terms of technology, so they are all working in the sector. But this is a huge space for basically data science competitions, that if we have 10 more of these, I am sure there are competitions to run on them. So that's how we decided on working with Zindi in particular, and we have done, I think, 5 or 6 of them with Zindi so far. We have actually one running now in October. Yeah,
I'll put that in the show notes as well. Then, the reason I'm bringing it up is a lot of what I learned personally in data science and less remote sensing, but mostly data science and machine learning, was through Kaggle, driven data a little bit as well. But those competitions, I highly encourage people who want to learn about data science and to do those competitions, because they bring a common problem. It's a way to work on a project with a bunch of other people who are working on the exact same project, so who have a shared understanding of the problems that you're facing. And there's this, it's gamified basically, which is always pretty fun.
It is. No, definitely it's a good way to learn. And for us, the interest is, now that they're interested in data science, let's also teach them Earth observation, right? Because we want to get more people into this sector. So that's definitely the interest for us. And many people have come to this sector, have come to our competitions, learned, and they're now successful in their journey and career. So we have seen people who have learned or get exposed to Earth observation the first time through our competition. Now they have their own company in Africa. So there are examples of that we see firsthand.
That's really cool, and that must be like really encouraging as well to see the direct impact. It is,
and rewarding that you feel you have had an impact. Yes.
You mentioned there was a challenge with external organizations who wanted to bring in their own data. Could you expand on that a little bit?
So the challenge there is many organizations that generate data sets, particularly I'm talking about training data sets, they are not necessarily software engineers. Sometimes they are researchers in a university. Sometimes they are a small organization. Rarely they are like a commercial entity that has geospatial background and expertise, and they have software people in their team. So the way they generate the data in terms of format, structure, and everything, it is not ready to be ingested to ML Hub. So when the data set comes to us, we have to still invest time in making sure the formatting is good. Sometimes we do this back and forth with the data provider if they have capacity. If not, we decide, do we have the capacity internally to do that? And then after the structure is good, then you need to do the cataloging. So all the stack catalog generation and ingestion is also a process. initially we invested in making sure we can do this internally well. So we didn't invest in training people outside to do that. But now that we are scaling, our focus has shifted how we can empower them. They have the right tool, they have the right knowledge to do some of that lifting on their own, so we can easily ingest the data on our own, and we can basically scale this ecosystem, because we can't go and catalog. Basically, we can't go and structure and format every single data set that comes to ML Hub. And it has matured enough now that people know about the value, so they can invest in that resources on their end. So some of this work is through funders, for example, through the NASA agreement that we have. They have grantees who are generating training data sets. So, for example, we had webinars for them. We taught them, okay, this is how you would structure your data if you're generating a training data. Make sure you follow these steps. So when the data comes to us, it is easy to be cataloged and ingested, basically. Some of it is community resources, so building, again, more tutorials and tools out there that people can do that. But at the same time, acknowledging this is not an easy problem, because geospatial data is hard and complex. And it is not just one format. It is not just rasters, right? You have polygons, sometimes you have time series, sometimes you have sparse data around the world. And training data is also different than mission data like Sentinel-2 scenes because of being sparse around the world or your area of interest. So that's the challenge. But again, there is also interest both from funders and our community that, hey, we want to do this better. So as a community, we want to advance, so we do this together. So that's part of the focus from us in the next years come.
Yeah, this is something interesting I wanted to touch on as well, is that machine learning tends to be the, or at least the model building aspect in machine learning tends to be the sexy part of it, and the data engineering, which is getting to a point where you can train a model and then deploying it as a whole other problem, gets a little bit less attention about this whole cleaning the data, making sure that it's standardized, that there's a format that you can find it. Is that something, I mean, you mentioned it there, but is there other work that you're doing on trying to build capacity on that? Stack is probably one of the Spatial Temporal Asset Catalog. And how are you thinking about splitting time and effort on not just the machine learning part, but making sure people can actually get to that part in the first place?
Yeah, I mean, the point you raised about the complexity and the effort needed in data engineering is one of the reasons we established ML Hub, right? Because if one group, one entity is going through that process, generating a good quality training data, someone else should have easy access to that, particularly if it's going to be open source. So it should be hosted somewhere in a standard format, standard catalog permanently, so someone can access it. So that's one of the motivations to establish ML Hub. And it is a heavy process. Things that we do there is, the stack is one of that process, but the other aspect is, again, how you do that training data generation. Examples of that is, for example, when we were doing the LandCoverNet training data set, it wasn't just about, again, data engineering, it's about knowing the domain problem. So when you do image annotation on Sentinel-2 and you're identifying land cover classes, you know that even human beings have some error, right? No one is going to be 100% correct on those annotations. Beyond that, when you're using a crowd of like 20 people, as much as they are trained and knowledgeable about what they're doing, they're not like crowdsourcing, they are paid and basically trained people. They might not agree on the same class, because at 10-meter resolution, you don't necessarily see the class, the land cover classes specifically. So when we designed that training data set, we said, okay, the way we are going to do this is we will have 3 independent people label the same image, and then we will build a consensus among those 3. So right. This is showing the art of possible, basically, through that process to the people that, hey, you're generating a training data, you should be aware of these uncertainties, and this is an example of how you would treat that uncertainty. And when you access ML Hub, access LandCoverNet on ML Hub now, you get the land cover class in the training data set, and you also get a consensus score. So you know how much were those annotators in agreement in terms of that class. And hopefully we can feed those to our machine learning models. There's research going in that space now that the model doesn't treat that label as 100% accurate, but there is some level of uncertainty to it. The other aspect is when you're doing ground referencing on the ground. So in many of the agricultural applications, you need to be on the ground to collect your label, whether it's the crop type, whether it's the field boundary, crop yield, or any other kind of agricultural practices. You want to make sure when you're collecting that data, which is part of your data engineering, you have the right metadata so you can then match it with the right imagery and generate a good quality training data. So what we did there was working with, through the funding from actually the Bill and Melinda Gates Foundation, the ECAS program that I mentioned, and working with one of the Android apps called ODK, Open Data Kit. And we have now a standard questionnaire, which when you want to do agricultural ground referencing, you can collect the right metadata on the ground and generate a high quality label. And then Radiance of the world can use that label, bundle it with Sentinel-2 or any other type of imagery and generate a high quality training data. And we are using that now in projects with our partners who are doing data collection on the ground. So we have invested in some of those resources to make sure, again, we show what is possible and how we can do it on the ground in the right way. So we have a high quality training data at the end.
Right. I understand. So there's a lot of work in creating those data sets that goes in as well. Yeah. This makes me think, like, who's the target audience, if I can use that word? Like, who are you building the ML Hub for? Is it for, I want to say, regular data scientists who have an interest in, they need satellite imagery for one thing, or are you specifically looking after geospatial people who are then trying to bring in machine learning, or both?
It is both of them. So it is people who have familiarity with geospatial but interested in using machine learning, data science, broadly speaking, on those data. So they need to access an existing training data, try piloting an idea or just exploring. There's also the data scientist who may not be exposed to Earth observation yet, but they want to see what is the art of possible. So they want to just, again, grab a data set. They might come from a Kaggle competition, which is pretty much a computer vision thing, but they say, okay, what is this geospatial thing? And we have data sets specifically that are simpler. They're smaller in size. They have typical kind of computer vision problems, segmentation, for example, or regression, and they can easily build a model. We also have notebooks in our tutorials that are just a baseline model. So you don't need to even build your own model. You can just go through that notebook, reproduce one of the pipelines we have to see how you would build a model using an existing training data set on ML Hub. So we are targeting both of them in some sense. And in our training and capacity, we have done both of them at the same time. We have had groups that come from a geospatial background. So we try to focus more on the ML topics when we go to those trainings. And then we have people who come from the ML world, particularly when, for example, I give a lecture at one of the DP in Double ones. They are all ML people, so they know all the concepts of ML. You don't want to talk about those, but you want to show them how those are being used in Earth observation and how they're solving problems, what are the benefits, and what are the challenges.
Right. I want to get back then on the on what you started with on the early when we started talking about. You described yourself as in between researcher and executive. Some of the work that you've been doing, you've been the executive director for Radiant Earth for a couple of years, I think. And I wanted to talk a little bit about what that was like for you, coming from a researcher background, having this role that there's a research aspect to it, but it's mostly executive. It's like leading the team. How has that been? How's that transition been? How did you go through that?
So I mean, as I mentioned, when I joined Radiant, I was a technical person, right? I was a senior geospatial data scientist. Gradually, with the basically proposal about ML Hub, which I led all of that idea and the development, and also getting funding for it, writing proposals. I was leading the ML portfolio of work at Radiant, if I may call it. And I think a year after, I was promoted to lead data scientist, basically. If I add, there was also a technology solution Radiant was providing back then, which was more on satellite imagery, a platform that people can easily access the data and everything. So Radiant has already had a technology stack basically. But ML was what I brought to the team and started expanding in terms of scope, funding, and potential roadmap for the future. At some point in 2019, the organization as a whole made a decision to pivot, particularly on the ML part. So that's where I was basically promoted to chief data scientist. So I was the technology lead for the whole organization, working closely with our CEO, and we shut down the whole platform thing. We can talk about that later. But that's how I became to basically a technical leader back then. Then gradually, the organization was shifting heavily more toward ML. It was all doing machine learning, particularly on ML Hub, and also working on some of the actual model developments. An opportunity came up for me to be the executive for the organization. To be honest, I was a little hesitant myself. I wasn't sure if I want to be a technology leader or an executive, but it was an opportunity I could try. And one thing that I did was I had basically two positions the last 2 years. I was both chief data scientist and executive director. So I was still leading the technical team, but I was also full-time executive director, leading the organization in terms of business, fundraising, budgeting, operations, and everything. So it was a lot, but it was a natural, I think, path for me because I had interest in running things and being on the executive side. And I tested it in some sense. The board also, I think, had a good trust in me, and I'm really thankful to them for that trust, and also supporting me through the last 2 years for that. And it was very satisfying, honestly, having the both of those roles. But gradually, I knew those roles should split because it wasn't scalable in some sense. I mean, we were small enough that I could do both of that. But now at this time, Radian has a lead data scientist, has an engineering manager, and a separate executive director. So those roles are now split. And it was a natural split even if I had stayed with Radian longer.
Yeah, so now you've stepped down, but you're still on the board for Radiant Earth. And so I'd like to go looking a little bit forward. What is your role going to be on the board? And then on the work that you're going to do down the line?
Yes, so I mean, on the board, everybody on the board of Radian helps in some capacity, depending on their background, their expertise. I mean, given my involvement with Radian, I will be more hands-on, if I may say, with our new executive director, Jed Sandwall, because I have had a good, basically, legacy in Radian, if I may call it, the last 5 years or so. I know a lot of the details. So I'm going to be available to him in that resource, particularly thinking about the next stage of fundraising and business development. At the same time, I've promised the technical team, if any resources I can be helpful to them, I'm happy to provide that help, basically. That's how we engage with the board, broadly speaking. Some of them help with fundraising, some of them help with technical stuff, some of them help with networking, connecting with people. So that's the function of the board, basically. And my role will be more closer to the team, given my history at the organization, yes.
And then you're moving back to academia.
Moving back to academia, yeah, it was an unexpected turn, I think, for me. But again, another opportunity came up, and I gauged it very, very, I would say, thoughtfully to see if this is the right path for me. So starting January, I will be joining Clark University here in Massachusetts as the director of a new research center called Center for Geospatial Analytics, and also at the same time an associate professor in the School of Geography. Clark is known for geography for years and decades, and now they are at the intersection of the next, I would say, wave of geographical and geospatial analytics. So that's why the new center is being established. And they were specifically looking for someone who has a research and academic background, but has been outside of academia. So they can think more broadly, not necessarily in a commercial sense, but in a non-academic sense, let's put it that way. Who can build relationship with outside, who can bring funding, and also build a good analytic team internally in the university.
So what's some of the work that you're going to be doing there? What are some of the things you're excited about?
Yeah, I mean, so the vision for that center is, as I just alluded to that, many faculty, for example, in the School of Geography, are doing geospatial analytics. They're building models. They're doing various types of analysis at various spatial scales. Some are very regional in a city or urban area. Some are doing global mapping. And historically, they have been doing analytic, whether on their local server or an HPC in the university. There's kind of scattered technology around. One of the roles this center will play is bringing a shared set of resources, identifying those basically common denominators of how we can build a technology stack that will benefit everyone, and also human resources. Going back to my comment earlier about the challenges with data ingestion, and this is, I have been a PhD student, I have done research in academic myself. Academics are not trained to be software engineers, particularly if you're not in a CS or EE, electrical engineering degree, right? We know programming, but we don't know software engineering, and they are very different things. Now that I have been in an industry basically job, I know that pretty well. So one of my visions is having human resources shared again between those research groups who can help them with software engineering and generally DevOps roles, because I'm sure doing that we can be more focus, we meaning the faculty, on doing the research and solving the problem rather than the engineering side of things. So that's a key role the center will play, and also building more relationships with the commercial sector out there, whether it's in terms of projects and fundraisings or doing consulting work on various domains and topics.
Right. Yeah. I totally went through that realization that like programming is one thing and software engineering is a whole other part that comes on top of it. That writing good code is a whole other level than writing code that works.
Exactly. Yeah.
I want to go on something completely different. You mentioned you were from Iran. One of the things I'd love to talk about, if you're comfortable talking about it, is how it has been coming from Iran, and you're now in the US and working there. I think it's a topic around that doesn't get that much attention, that it's really hard, depending on where you're born, to get different jobs in different countries. So I wanted to... again, if you're comfortable sharing about that, what your journey was like coming from Iran, coming to the US, working there.
Definitely. No, I'm happy to share and talk about that. And it is not an easy journey. Yes. I think looking at many friends and other people in the community who I know are from Iran, my journey has been smooth, but still it has been bumpy and hard. So the way you usually come is, for example, I applied for a PhD program. I got admitted to MIT, but then the first thing you need is get a visa and come to the US, right? But there's no diplomatic relationship between the two countries, so there's no embassy in Iran. The first thing is, where can I get a visa? So you need to go to a third country. Many of the neighboring countries in Iran provide that service. Go for an interview, come back home, wait for the visa itself. Usually Iranians go through what they call background check or a clearance process. So that might be a week, might be 6 months. You don't know that. So there's a lot of uncertainty built into that process itself. I was among the fortunate ones to get mine in time, pick it up, and then be on MIT campus for the start of the semester in fall 2009. But when you arrive, you have a single entry visa. Your visa is basically expired. You just have a status to be a student. You can't go back home easily, because if you go back, you have to do the same visa process again from scratch, and there is chances of not getting that visa again. There have been people who have been stuck like that. So I basically stayed in the US for 8.5 years, didn't leave, not going back home, nowhere basically, because if you leave US, you need a second visa to come back. You can't even go to Canada as easy as that. So that is hard, particularly for people like us who have very close ties to family. You want to be with your siblings, your parents. It is not easy. So, but to be honest and to credit, MIT community was very welcoming. So that's what I really benefited from. Both advisors, student groups. The whole university is designed in a system that welcomes internationals and provides a lot of support for them. So I really appreciate that support I got from MIT. And then I went through the basically green card application process. Usually when you're Iranian, you get scrutinized more than the typical basically green card applicants. So mine took about 2.5 years,
Wow.
which was in itself a record to do that. As an MIT graduate, you usually get it much faster, but mine took 2.5 years. After that, you become almost a regular citizen. I mean, you're not a citizen in the sense of U.S. citizenship, but I mean a citizen of the society. I didn't feel any time that I didn't have benefits. There are issues with being Iranian still. I mean, with green card, I can't access some of the national labs. So once I was invited to Oak Ridge National Lab for a workshop, they couldn't let me in because you're an Iranian. So there are those things that occasionally come up, but for me personally, it's like, okay, that's part of the society and immigration basically experiment I have here. I'm not shocked anymore when I hear those things. People who invite me and then hear from their administration they can't let me in, they are very sorry for that. They reach out, they talk to me, and I'm like, no problem. Honestly, I'm aware of that's a process I'm expecting anytime. But I've tried to basically adapt my life around that. I don't feel I have been stopped in some sense. And yeah, I travel back and forth. Everything has been normal, but that first 8 to 9 years, it is hard to get settled in this society. Yeah, and in addition to that, the whole global situation and the back and forth basically fight between the countries doesn't help in your regular life. You read the news, you connect with family. There's always this growing concern of what will happen next. But even if I was in Iran, I think that was a concern. That is not necessarily specific to my immigration here. Yeah.
Do you have advice for people who might not be in the US or bundle Europe the same? I've realized that the European passport I have is probably the most valuable thing I have and own, and slowly realizing that that's not the case for everybody. The internet is a wonderful place to have access to conversations like this. You don't need to be anywhere, but there's still value in being present in certain countries over others. Do you have advice? What would you say to people who might be listening? Because there are some people who are listening to these who aren't from the US or Europe. What advice would you have for them?
There are many topics I can pick on sharing an advice. If I want to talk about the technologies that I believe the remote sensing data, broadly speaking, satellite imagery, has a huge benefit actually outside of US and Europe. We are capturing the same quality and cadence of data from like Sentinel of the world in the US and Europe and the other parts of the world, but they are highly underutilized in those parts, and they can solve problems that can go way further in terms of impact than what we have in the US and Europe. So one recommendation is get to know this technology and look at problems that you can solve in your society and in your community. There are good examples from the basically US and Europe, but you don't need to necessarily use that. Adapt it, don't adopt it. I always talk about this terminology. You don't need to use the same thing. See how does it fit in your context. So get to know this technology. It can help many verticals. You have talked in this podcast a lot about it. It can be agriculture, it can be health, it can be infrastructure and roads, it can be weather. There are many domains that this technology can help. So tap into this technology, learn about it, reach out to the people. Geospatial community, I see it as a very open and collaborative community. This is something I really value in our community. So reach out to the people and ask questions and ask for their advice or feedback. They are very open. So use that human resources that is available to you, whether on Twitter, LinkedIn, or any other platform. So also Radiant, I'm sure our team will be happy to help with questions. So tap into those resources if you are learning about that. I agree with the basically online presence that we have, podcasts, webinars, and things, but I still feel the in-person connection is a different thing. I mean, particularly during COVID, I experienced that, and I think many people did the same thing, doing all the virtual ones, and at some point getting tired of, okay, this is just the same Zoom window I'm looking at all day, right? So where is the in-person interaction? I remember the first conference I went to, since the start of the pandemic. I don't want to say after the pandemic because it's not over yet. It was the ESA Living Planet Symposium, and I was like, oh, this is how it felt to do conferences back then. This is the human connection we had, and we have lost basically. It was unusual a little bit for me, but since then I'm like, if there's a meeting, there is a value in to go and get, and I can build a connection, I can have an impact, I'm going to do it in person because it is a significant difference. So if you have the opportunity to attend a meeting, definitely go. You learn much better. You connect with people. There's significant value in connecting with people in person, learning with them, and also having that personal connection, because you can reach out to them again in future or build a connection or collaboration with them. So these two are, I think, the main suggestions or feedbacks I will have. There are many people who also, like me, come to the US or Europe, gain a tech experience, a degree or something, and they go back into their society. So if you have that opportunity, that's also definitely valuable. But there is growing interest from particularly philanthropic side to support those kind of people who are going back to their local communities to build a technology solution in many sectors. So you can tap into those resources in terms of funding and fellowships to get support and coming back to your society to build solutions. So if you're interested in that, check out those resources and grants, basically.
One last thing this brings to mind is English is the dominant language in the Western world. In Europe, it's a bit of a different scenario, but it still is like the language that is spoken on the internet and everywhere. And yet most people in the world don't speak it. Is that something, that's a whole other body of work, but is that something that you've been thinking about?
It is definitely. One suggestion we had internally at Radian was that we should publish some of our tutorials in Spanish and French. I mean, at least they are the second and third kind of dominant language. Many African countries speak French, particularly in the West Africa region. And speaking of Latin America, you can reach a broader community with that. So there are things like that we will try to do. On a personal level, I haven't learned any other language, so that may not be. I know Farsi, definitely. I know a little bit of Arabic and English, definitely. But I think this is I don't think there's a solution necessarily to it, right? Because English is the dominant kind of official language everywhere. In any international meeting you go, people speak English almost. Any online website has an English version of it, if not more than that. Maybe it's a good thing because we have a common tool to talk to each other. But I know it is a problem at the same time because you're then forcing everybody to learn English. I think that's where potentially technology can help us. The kind of real-time translation tools, whether it's in your glass that you're looking at the screen, whether it's the screen itself, whether it's the audio translation, that's probably the role that the technology can play to help us have better AI, better translations basically in real time. There has been a lot of good advancements there, and I'm sure we will have a much smoother experience there. So I don't see that as a problem, but I'm sure many people in the NLP and the natural language processing, NLP, are working on that type of problem. There's a lot of, speaking of training data, there's a lot of funding and investment in training data sets for African languages. So we can have better NLP models on those languages. So this is a good effort in that community, which I'm sure it will have fruits soon and people will benefit from that.
Yeah, that makes sense. I have to say I'm a bit, I think part of me would be a little bit sad if we had great translation. I know it would open up a lot of things, but I'm very fortunate enough to be fluent in 2 languages, and I have to say I think it's one of the most eye-opening things. Like I feel like the words that you use limit how you think, and speaking more languages helps on that. And I think we would rob ourselves from some experiences if we had that. It would help for a lot of things, but I'm a little bit conflicted on that aspect.
That's a good point. I mean, now I think about it, I have sometimes the same problem between English and Farsi, because I talk something in English and I want to translate it to Farsi. I'm like, it is not the same thing, right?
Yes.
You have that problem sometimes. I agree. Yeah, it is not the best way to communicate. Maybe it's just the first way to start a communication,
Yeah.
but it is not definitely the ideal way of doing that. Yes.
And I think it's a cost benefit trade-off, like a lot of things. Like if you can make a lot of content, a lot of tutorials, resources, movies, you name it, accessible to a lot of people, maybe that's a trade-off that's worth it.
Exactly.
So I just like how I like starting these conversations, I like rounding them off by asking people for books and recommendations, which also feels like a great segue after talking about languages. I mostly ask because books and podcasts travel a lot through word of mouth. There's a little bit of recommendation online for books and podcasts, but mostly it's through hearing people recommend them. And I think they're quite telling of how people think. So I'd like to ask if there's a book and a podcast that you've read recently, listened to recently, that you think is interesting, that's worth sharing. It doesn't have to be about geospatial. Actually, it's maybe more fun if it isn't. But just something that, has been on your mind and you think might be worth people reading, listening to.
I will go with a book suggestion. A book I recently finished called Atomic Habits, which was very resonating with the experience I had in there. So it talks about basically small habits that you should build in a life to change your habits or to change your character, basically, or the way you do life, the way you go about your daily things. And I will pick one example from there. It talked about the difference between identity and goal. For example, you don't want to set a goal to run a marathon because after that, you're done. You won't do any more running. But you want to change your identity to be a runner. And through that, you will probably run for a marathon. The whole book goes around this thing and how you can build that basically identity for yourself and also potentially pick up new identities throughout your life. I really enjoyed that book. I really recommend it to people. I'm one of those people who ran a half marathon once and never run after that for 6 months. So it resonated a lot with me when I read that book, that this is the problem. I set a goal for that, not necessarily an identity for myself. So yeah, that's my suggestion for that.
That's a great recommendation. I love it. I think it's by James Clear, if I recall correctly.
Yes.
It's a wonderful book. Yep.
It is, absolutely.
Hamid, thank you very much for your time, for coming on and talking to me about all the work that you've been doing.
Absolutely. It's a pleasure and fun to be here. Thanks for having me. And also thanks for the great podcast.
Thanks. And Radiant Earth has been supporting them for a little while. And I've been very grateful for that. So yeah. I'm glad we then had a conversation about all of this. Thank you very much.
Absolutely. Thank you.